El IICA le da la bienvenida a este evento y agradece su participación. Estas son algunas recomendaciones para mejorar la calidad de la videoconferencia. Habilite su micrófono solo en el momento que le den la palabra. Es importante mantenerlo en silencio cuando otra persona está hablando. Por favor, tener encendida la cámara en todo momento para que otras personas lo puedan ver. Si necesita atender algo personal, puede apagarla y encenderla al volver. Agradecemos por favor poner en silencio sus teléfonos celulares para evitar alguna interrupción en la videoconferencia. Recomendamos cuide su postura y su posición frente al computador. Para esta reunión contaremos con interpretación simultánea. Es muy importante que cuando ingrese al enlace de Zoom del idioma de su preferencia, debe hablar en ese idioma. Por ejemplo, si ingreso al enlace de español, debe hablar en español en todo momento. Al finalizar el video, les pedimos el favor de hacer silencio durante 30 segundos. Una vez finalizado ese tiempo, el moderador o conductor puede iniciar la reunión. Muchas gracias por su atención.
Morning, everyone. I'm going to make my opening remarks in English for the interpreters, and then I will invite my colleague, Dr. Susana Flores from INIFAP, the head of the task force, to say a few opening remarks in Spanish. There's an echo in the room. So I'd ask anybody in the room turn off their phones. If you need to take a call, just step outside, no problem at all. And there's live interpretation in the room through Zoom. If you want to listen to it, you have to have your phone to be able to follow the Zoom room with interpretation from Costa Rica. My name is Jean-Charles Vallée. I'm the country representative for ICA in Canada. I'm based in Ottawa. I'm also the secretary for Poste Norte. You'll find the description of Poste Norte in front of you on the tables. We are 26 years old. Last year, we did a beautiful anniversary, our 25th anniversary in Casa de las Americas here in Mexico City. Wonderful event. And we have various task forces. We work on plant health. We work on gene banks and genetic resources. We work on climate change, soils, and water. And today we're celebrating animal health. That's very, very important sets of issues, way beyond the three that we're talking about the next 3 days. But the main focus for the next 3 days will be on African swine fever, bird flu, and bovine tuberculosis. I'm very happy to know that we've maxed out our Zoom space online. 500 people have registered. They're really excited about these topics and they're priority issues for our member states. ICA has 34 member states, so we have participation from Canada all the way down to Argentina. Across the Caribbean, there's a lot of interest in these issues. And so I will invite the speakers who are in this room throughout the day in English, and my colleague Susana Flores, she will invite in Spanish. So we co-preside the event today, the workshop, throughout the whole day. There are no breaks, so if you need to get up for coffee, snacks, bathrooms are just to the left outside the room. There's coffee in the back. Lunch will be around 11:30. And we'll have an hour and a half break and we'll start back at 1 o'clock Mexican time. That's for people online, so there'll be a 90-minute break. That's pretty much it in terms of interpretation. In the Zoom room, I would highly recommend all speakers and the public listening to us to go down to the bottom center right. You'll see a globe. It looks like a world. If there's an interpretation button, please stick to one language throughout the day. Don't swap. It's easier for interpreters and it makes for a better experience online. I'm here throughout the day. If you have any questions about Poste Norte, you're looking to collaborate with us, happy to chat over lunch at the breaks. And I'd like now to invite Dr. Susana Flores, the head of our Animal Health Task Force, to say a few words.
Gracias. Hola, muy buenos días a todos. Mi nombre es Susana Flores.
Hello, good morning. My name is Susana Flores. I am acting as the head of animal health and safety and the representative of this task force of health, animal health. It is a network that we have as witness to favor
conocimientos,
the ideas and knowledge and priorities. This among three nations, the United States, Canada, and Mexico. But as it was being mentioned, we have a long history of cooperation with different countries from all Latin America. This year, we also have the participation of ORISA, IORA, from all the countries of the Pan American region that are going to help us and give us some advancements in regard to the animal health, if, about it, swine fever and other illnesses. So those who are present here to try to promote this collaboration. Our work, we also have a long history of collaboration projects, and we have demonstrated that this mechanism that brings us all together here is favoring us for the exchange. So the invitation is to continue on doing it. For those people who are online, you can send your comments through the social network, or if not, each presenter is going to have their data so that you can share and that you may be able to present all that. You can also contact us directly, the speakers are from the task force, and we will be more than happy to help you channelize your.
Hemos elegido tres enfermedades. Como ustedes bien saben, la influenza aviar es una enfermedad.
We have chosen three illnesses. There is an illness that is very prevalent, and we have, but instead of trying to focus on the illnesses, we're also going to talk about some swine fever. It also has a very important part that is a very high impact in the clinical health and the animal health. That is why the reason of this presentation. So without further ado, I'm going to give you the warmest welcome. I don't know if anybody else wants to say something. From the Task Force of Canada, I don't know if he wants to say something. So without further ado,
Vamos a darle el tiempo a nuestro
so we're going to give the time to our coordinator, José Luis Ayala, so that he can give us some opening remarks.
Bueno, pues buenos días a todas y a todos.
Good morning to all of you. It's really a pleasure to be here on behalf of the Dr. Diego Montenegro, the representative of Mexico. We greet you very kindly. We give you the warmest welcome to this very important event, and to congratulate the organizers of this event, Daisy, Susana, who accompany us here. And we also have Gloria on the way, also Berting. They don't see you, but they are behind curtains. All the technology making this possible, and of course, all of you. Those who are here in person or virtually, we give you the warmest welcome. And let me make a small reflection here. Last week, I was with the director, the general director of the Cine, who was Brand Robert, and we were doing an exchange of ideas that seemed to us very important to share in this forum. Two data to mention. The platform of the European Union, Copernicus, that has been monitoring, among other variables, the temperature. It has said that in the year 2023, it had been the year with a record recording of higher temperatures since data has been collected since 1840. But nevertheless, in 2024, the graphs that have been showing us day to day, from January to May the 31st, which is the data that I have in front of me right now, It shows that all the temperatures, all the daily temperatures are above those of 2023 and, of course, of the previous years. In other words, once again, we are facing a scenario of record high temperatures. On the other hand, another variable, water. The National Water Commission of Mexico has a data these days where it mentions that the yearly rainfall that we have records of from October 2023 to May 2024 have a reduction of 8.6% with regard to the last 30 years. In other words, temperature and the rainfall in a scenario of climate change represent a challenge. And well, that is something that we already know with precision and writing down the context. So it is undoubtedly the research, the science are a fundamental part to be able to face these challenges. Great researchers that are here present today are working, trying to find a way of overcoming all these challenges. Nevertheless, talking with Bram Robert, he was telling me that in the topic of the production of corn and wheat, that it took us about 25 years to generate a variety that would adapt by producers with certain characteristics, certain uh, relevant characteristics to be able to face plagues and illnesses and this type of climate changes. Talking about this scenario in the research right now is really something impossible to be able to overcome these challenges. As a matter of fact, that period has been reduced to approximately 5 years, but nevertheless, it's not enough to be able to overcome these challenges. So the invitation is, let's do research, let's do science with the prospect not to 2030, not to 2050. Let's make it all the way up to 220, 2100, 2100. None of us are going to be here, but if you have a daughter or a son that is 5 years old, probably they're going to have to live this. But thinking about the scenario for the future generations, it is really a big challenge that impacts the agro-food systems, especially the livestock in a broader sense, poultry, porcine, fishery, etc. And it is important to take into consideration scenarios that are going to be seen 2100, so that from this moment we can start working with human health. What you're doing here is really something that can make the difference so that we might have the necessary tools to be able to face better this in the future. So I thank you, I congratulate you for the initiatives that you're going to be sharing in this event, and I wish you the best of the success. Thank you very much. Well, thank you very much. Now, without further ado, we are going to give the welcome to our first presenter, who is Professor Alcázar. He's going to talk about the current situation of something. Sorry, I couldn't hear what she was saying. The current situation of the avian flu in Mexico. That's what he's going to present about. I don't know if it's possible, so that we can turn down the lights so that we can see the presentation a little bit better. Well, thank you very much for the invitation. Good morning to all of you. And this opportunity, and the topic that they requested us to present to you on behalf of the current situation of the avian flu in Mexico. as it was just mentioned. But in reality, it is very important to take into account all the changes that are taking place in the climate change, everything that is happening, that is not something common, that it was not normal, and that effectively this has very drastic consequences, especially talking about animal production, which is our stronghold, and especially because of its consequences to the public health. This is really a change that we have noticed recently. We are living it with the behavior of the illnesses. That is the case of the avian flu. That, as mentioned before, it is an illness that in the last few days or the last few months has had a very important growth in the sense that there is a lot of mention being done regarding the illness for situations that are not normal because it didn't behave that way previously. The case of avian flu, bovine, the case of bovine avian flu in bovines passed on to humans. That is what concerns us. And from the point of view of our competency, we have to take actions precisely to prevent and to avoid certain type of outbreaks of other types. So, well, we're going to give way to this. And could you please pass it on to the next one? Next slide. Okay, we're going to talk about the preamble. We all know what is avian flu. It is a highly contagious viral flu illness. And if we talk about the types that we have, which are the ones that are in mandatory notification to the OMSA, and that they can be highly pathogenous, and that they have a great affections to the production, agriculture production. But not only the agricultural, but also it affects the wild species that are very important to the ecosystems, and it is important to protect them. But well, why to control and eradicate it? If we go to the production side, as a part of apiculture, it is important to know that at least Mexico, it is a country that is highly producer of avian products, both meat as well as eggs. And apart from that, when in this slide we can talk about the aviary production in Mexico, which is 221 billion pesos. For Mexico, this is very important. The production of eggs is 2,963,000 tons a year. This represents a value of 80 billion pesos. The volume of production of a chicken is 3 million tons, almost 4 million tons, and this has a value of a production of $140 billion pesos. Sorry, the agricultural production, the avian production. Sorry, we lost the sound, I think. We lost the connection.
Can you hear me?
It looks like we lost connection.
Yes, we can hear you.
Sorry for the inconvenience. Give me a few minutes, please.
Yes, we lost the connection, it seems. Sorry. The interpretation is still on, but there is nothing to interpret at this moment.
My apologies for the inconvenience. They are connecting again.
Pero pues no tenemos precedentes de este virus H5N2 en personas. Entonces, de
We
esta
don't have
manera,
a precedent of this virus, so therefore we cannot know if it's something that we still are not aware of. We don't know what the repercussions are in the public health. And the people that they reported as affected by this virus was a person that had comorbidities. He was affected severely in his health. And the fact that he now represented this, that they have detected this, is a finding. Not necessarily this virus is the one that caused the death of this person, but it is something that is important to take into account. The previous one, it seems to me. Within the challenge that we have as veterinarians, the knowledge that the wild migrating birds are an important reservoir of the avian flu virus. So although these birds might not necessarily be affected, and there it might behave like a low pathogenicity virus by being in contact with a domestic birds. We might have the problem that we had with avian flu. So the contact of these wild birds with the phenotropic birds, as we call them in Mexico, it is the leap that this virus does become high pathogenicity. And so one way or another, this is one of the important challenges that we have for the agriculture. Next one, please. Well, in these images, slides, can you go back, please? We can see how the migrating birds interact with the birds that we find in our countries. The philanthropic birds, the resident birds in the zones where we have the bodies of water, the wetlands, and that these birds have contact with the farms, so the poultry farms that are found in the place. And all this because of the lack of efficiency of the biosecurity measures that some of the producers have, some agricultures. And this is the important thing that it might outlace outbreaks. And we can see some images of some of the farms that have very poor biosecurity measures. There's some studies, like for example, the screen mesh and so forth that avoids the incoming of resident birds in the zone, and that previously were in contact with wild birds. Next slide, please. This is what happens on the field. What we have observed is that when there is the presence of wild birds and wetlands and bodies of water, birds that carry the avian flu, for example, H1N1. For example, when we have found high risk in the philanthropic and crow, black crow, and so forth that we can find in any part of the country, and we can, if we go out and we can see the trees, we're going to find this type of birds. That we are basically flooded with those birds, and they are looking for food at the same time, so we can find them in the farms, we can find them close to the housings, and well, it is a risk factor because we have also found the virus in these birds, and some of the cases that has caused mortality. We have found mortality of this type of birds with the presence of the virus. We have also found serology. We have found the virus in healthy birds, and these type of birds are in contact with farm birds, and that's where we have had important outbreaks. Well, what happens in Mexico? Well, the actions that are carried out by Seneca for the prevention of avian flu is by the monitoring at farms. Every year we have a program of surveillance where we take into consideration sampling and commercial birds. We also carry out sampling and transfers. And we have a statistical sampling that is determined every year, and that the main purpose of the objective is to observe the circulation of the virus in these type of species. Apart from that, we also do surveillance on basis on wild. Many times it's not possible to detect the virus in commercial farms because we cannot cover everything. It is a very representative size that we do, our sampling. But in the places of slaughter, we can detect it, and we have been able to detect many of those virus, as we'll see further on. I don't know why the screen changed. Okay, and apart from this, we also have a team that carries out surveillance of birds in wild areas. There's a team of biologists that carry out wherever there is the risk areas. For example, where we have wetlands or bodies of water that are close to farms, we do the capturing of this type of birds, and we take samples, both of the stomach to see the virological, as well as samples of soil to see what the circulation of the virus is prior to the presence of antibody. And also, when we have an identified outbreak, the commercial agriculture, we monitor the wild birds that are circulating around. And what we have found is that effectively, many of the birds that we find wild birds, they are bearing the virus or they have presence of that. And another one of the situations that we do is the previous one, the attention of and notices. Passive surveillance is very important. And when we attend to any report that we have suspicions of the illness or that we report the presence of clinical signs that are compatible to avian flu with a high mortality rate of birds. Well, this is something that is reported. We provide attention with all the biosecurity protocols. We do the diagnose in our high security labs. And once the virus is detected, we apply the counteracting measures. Next one, please. What is the situation of avian flu in Mexico in regard to H5N1? Well, this virus was found here in Mexico for the first time in October 2022. And the situation took place because of a report that was done through passive surveillance. A veterinary doctor who reported a hawk with some symptomology that is found this, and this animal passed, and they found some injuries that were compatible with that virus. That was the first virus identified in Mexico. Based on this, we found other events that take place. After that, we found it in wetlands in Jalisco, which is an agricultural production, poultry production, and then later it appeared in other places, as it was expected. In 2022, when we had the first detection up to this year, we have detected 74 cases in 15 states that have been affected by this virus. As we can see, the majority of the cases that we saw were located in Yucatan. It is something curious that, especially because this is a state that we consider a free state, the Peninsula of Yucatan. It is a territory that for us is the one that has the best sanitary condition, but nevertheless, the presence of the wild migrating birds that activated the virus in its own. So it's one of the states that was affected, the biggest proportion. Regarding to the commercial, there were several farms, as you can see here in the graph, 20 agricultural farms that were affected. And in the rest of the country, we have had the presence of the virus, not necessarily the commercial. Some of them have been in the backyards and wild birds. And we have seen that in all the country, we have identified the circulation of the virus. But fortunately, in the second period, there were less affected commercial birds. The first period, we're talking from October to March, which was the last case that we identified in 2023. And well, that's when we found 33 farms affected, some backyards that had a certain consumption, wild birds. And in the second period, which was basically 23, in the year 2023 to 24, only 2 farms, agricultural farms, commercial poultry farms were affected. The rest of them were done in the backyards, wild birds, but somehow the infections were less.
This virus obviously was looking mortality that was greater than commercial, and whatever the virus was, there was elevated mortality. So this meant the activation of a national emergency device for animal health in Mexico. This is like the tool, the legal basis that we have to be able to carry out extraordinary actions that can be they are considered within our legislation, and they will allow us to react very quickly and in time with additional resources so that we can control whatever influenza outbreaks we have. And we still have ongoing, it's about to finish the intervention of INESA, and the truth is that the actions that were applied were effective, they were very efficient. And what we were able to do is to make sure that the virus presence was reduced, and in the commercial bird farms, it was under control. What is the situation regarding the type H7N3? It's worth mentioning that the time frame that we are talking about here is to be to be the same as H5N2. It's from 22 to 24. And from 2022 to 2024 is the same period that we are assessing for the for the subtype H7N3. It's a high pathogen strand that is also present in Mexico. It started in Mexico in 2012, and every year we had a presence in the virus in a smaller or greater proportion. And since the vaccine for to prevent this disease is available in Mexico and is still used as a control measure, then the effect on commercial bird farms is less. We do have virus presence, but we don't have higher mortality or any symptoms associated to the disease, although we applied control measures to avoid it moving to other areas. Here we have 96 cases that have been identified in 10 different states in the country. And as you can see here in this map, the biggest concentration of the presence is in the center and north of the country, but this is not at a national level like we do see with the H5N1. And here, one of the states that was greater affected was Coahuila and Durango due to an outbreak that happened in 2022, an outbreak of H7N3 in which it was affected the the producing the laying birds that were identified in these states, in this farm. So that's why we see them with a darker color, because that's where we had more cases. And then Jalisco is also another state where we have seen presence of this, regardless of having the vaccine for the virus, and we have a less presence of it. Another limitation is the sub-classification, because a lot of times during commercial farming, we don't, it's not reported, and we are not able to keep it control of it. But this we see it when there's a clinical mortality. We see when there's a clinical mortality rise, and that's when we're able to see it. Then in the Corredor of Huacalca in the part of, of Puebla, there's the farm, bird farm part of Puebla that have H7N3 presence, although it doesn't have a high effect on the farming activity because there's no high mortality, although we are detecting a lot of virus there. Why do I mention this? Because there's the presence of H7N3 in backyards, reports that were giving to us with high mortality, almost 100% mortality on backyard farming, and they were nearby the commercial farms. So this created a project to get a diagnostics to get to know what was the source or the prevalence of this virus in those areas. And so important for us as well, the agricultural in Puebla. And we've been able to find different cases, as you can see here in the chart. You have 12 cases identified in Puebla, and we still have a monitoring activity, a surveillance activity, where we have a sample of every farm every month now for virology samples, and we take samples on the serology and we have very interesting results from it. Aside from this, also the bird farming, not the bird farming, but close to bird farming is the wild birds that we were monitoring as well, and we have important information from them as well. Regarding H5N2, well, as I said before, last week we had information in the news about the virus H5N2 on people. And I want to say that this virus has been located in Mexico since 1994, when at that point was a high pathology virus. and it came into the country with a high pathology, and we have it in Mexico since 95, behaving as a low pathology virus. And year after year, we find or we see presence of the virus because since this is a low pathogenesis virus, there's no clinical evidence in commercial bird farming. There's no high mortality, although in the monitoring that we do with different farms, we find presence of the virus. We can see here as well the comparison, at the period that was assessed, 2022 to 2024, and we have 170 cases detections that we had in this scale of this virus in 21 states, and we see that the distribution at a national level, it's also important. In fact, we have found it in areas that were considered free before. There is clear evidence of the virus. It could be in serology or virology, but it still has presence in the entire country. And since this is a virus that has been available in Mexico for a long time, for us, the detection, it's not so much as an emergency in animal health. It is important, but it's not an emergency because derived from this, well, we had several comments, several communications, and for us, so what's going to happen? What is Mexico doing? What are we doing as animal health services? And so the response here that we are trying to do to these activities for the surveillance of this virus is because I want to let you know that all the viruses we found with bird flu, we do all the necessary testings that we do here in Mexico, and from the PCR, the viral isolation to the circulation, and this has allowed us to have a clear image of this virus and how does it behave, how the genetics of it behave. And in this case, what we were able to identify with the virus that was detected in people was that that virus has an homology 99% with the virus that we have reported 2 months ago in the state of Mexico. And but these activities that we did back then are daily activities. That's what I wanted you to know. That for animal health services, we don't see an emergency per se. We continue to complete our activities as normal operations. We have other parts of Mexico where we're doing samplings to get to know the presence of the virus, and so far we haven't found any additional evidence on the presence of the virus. Next slide, please. In this graph, we're trying to represent the detection of the virus, the bird flu virus, and H5N2 and H5N3 and H7N3. And you can see that in the case of H7N3, the greatest number of virus that we have detected has been in long-lived birds, such as the commercial producers. And why? Because they have vaccinations, and in the monitoring that we do, we're able to find the evidence of the virus, but we don't have any technology. H5N2, most of the inspections that we had with H5N2 is in the in meat chicken, and it's just traces that we've seen. And for the H5N1, the detections were most of them were the long-lived birds and of course wild birds, but that's the way that we have detected this diseases. And just to get to let you know, these are the areas where we have more detections and more inspections. Next slide, please. Of course, whatever action we do to contain the situation are diverse. One of them is the activation of INESA, that, like I said before, it happened for the H7N3 and for H5N1. And the measures that we have implemented aside from the notifying the WHO when we allocate a virus with high pathogenesis, and we have the quarantine and the different control measurements, additional activities that was done here created by INESA, is that we needed to have veterinarians, physicians that are responsible for each bird farm, and make sure that we stay in compliance with biosecurity, with emergency vaccination, control of the mobilizations, authorization of traces for the slaughter of long-lived birds. There's still a lot of traces on this, but specifically for the slaughter of long-lived birds. For the producers, and not all of them have the capacity to do so. So we enabled this registries to minimize the risk, to make sure that these birds do not cause any problems. And the intentions of this was also to make sure that the birds that are long life, they don't circulate along other live birds because that's a big challenge and a big risk, the presence of these birds. They already finished their reproductive cycle and they continue to be live birds. And a lot of times these birds, their final destination is not just consumption, but they go in the backyards and the virus continues to spread, especially because they are these long life birds. Now, if we go into the labs, particular labs that are approved by genetic to approve the diagnostics to in case to decide on mobilization. Next slide, please. And here we have some of the images of the actions that we have carried out in the production farms, such as reduction of population, cleaning, disinfection, the thermal treatment of the excretes. And then we have sanitary monitoring, sanitation controls. We can see here in some of the images and the support that we have from public security and the National Guard in the case of mobilizing. Next slide, please. And this is part of what we generally and continuously are trying to promote, to notify through different channels. Next slide, please. We have an emergency number, we have a process to get informed. And here we can see how the number of reports have been increased. Here we have a comparison from 2018, where we had a total of 117 reports that have been responded to suspicions of bird flu. And then in 2022, it was 522. Then in 2023, 472. We have a number for this year, but I don't have it with me right now. But we'll continue to see an increase in the amount of reports. And just as risk communications, this is a newsletter that we publish monthly. Now we are trying to change that periodicity to more often, but this is just information on everything that we see in New Mexico so that we have transparency of the information and what's moving around our country. Next slide, please. So the interinstitutional connection is very important so that we can approach this from environmental health, public health, and animal health. We have worked in two very important projects, such as a plan of coordination and articulation, and the emergency response with epidemic possibilities with zoonotic origin, and preparation to, and giving the possible outbreak of any zoonotic conditions with impact in the human beings. We have worked with the Secretariat of Health on this. Next slide, please. And every time we detect a virus or bird flu with high pathogenesis, we notify the health secretariat, and they create their own operations to monitor and the people that are in constant contact with birds, especially farm hens. And this is done every time we detect presence of a virus. And right now, this is going on. So this is how we move forward. We have advanced in biosecurity. We have we have a lot of measures. So 2,712 measures of biosecurity implemented. The state with the biggest number of measures applied is Jalisco, of course, because the number of production units that we have in that state. And then we have zootechnic conditions. Next slide. And now I'm past my time, so I would like to finish by saying that that's a conclusion, saying that bird flu is not a disease that is exclusive of animal health or veterinarian services. We have to approach it from the environmental health and public health point of view. And we are doing that. We are working with the coordination with other institutions and other authorities, and we are definitely working on the matter to approach it the right way. I thank you, everybody, for your attention. Have a great day. Well, thank you. Thank you very much to Carlos. We will leave the comments and questions for the end of the very first session before we go out to lunch. So please write down your questions for each of the speakers. We want to get started with a virtual presentations with the veterinarian and epidemiologist, Dr. Nestor Avendaño. Dr. Avendaño has experience in Ecuador and veterinarian service of Ecuador. He's been in charge of the national bird health system and porcine health system in his country, and he is implementing animal health project in AINA for the prevention control of respiratory zoonotic and diseases in both Central America and Dominican Republic, and is the representative of the regional program. I don't know if Dr. Avendaño, are you there? Can you hear us? I can hear you, yes. We hear you very well. Thank you, doctor. The floor is yours. Thank you very much. I would like to, first of all, thank you in behalf of Brodirsa for the opportunity to participate here. I'm going to be very concise. I know that this is a topic that is very important for all of us, right, in our biosecurity. I'm gonna focus specifically on the regional actions that we are doing and the zoonotic bird flu in the countries that are members of the OIRSA, and especially, and when some of you may know that OIRSA, then it's been made with member states, has different member states, which includes all of Central America, Dominican Republic, and Mexico. And as you probably know, all the sections
control, prevención y erradicación de enfermedades.
on the control and eradication of diseases, and this is because of the countries that we work with.
Siguiente, gracias. Bueno, breve
Next slide.
resumen.
Thank you. Yes, so just a small summary of bird flu, right? We all know that bird flu is highly contagious, and it attacks different domestic birds or wild birds, and it can also attack human beings. And recently, we've seen outbreaks on mammals and on aquatic species, which has affected the wild species as well as production birds. Generally, this virus is considered high or low. It's classified in high or low presence toxicity, and with the cause, we know the cause, right? It's a virus. It's an influenza A virus. It's one of the viruses that we know that affects birds but naturally and humans sometimes, and in porcine or pork and other species that might have an effect as well. Like it happened recently in the United States that it was detected the presence of this virus H5N1 with zoonotic origin in bovines in dairy farms that reported some cases. And then we have other subtypes. And then we have aminoacids, and we have 18 mallospirides, and then the new neuramidases. And then this virus in the pathogenesis, it's an acute disease in birds that is associated to H5 and H7 mostly. Next slide, please. The different species, as we mentioned before, these are, farm birds are mostly affected by more successfully. And also there's domestic aquatic birds, which is, a link between the wild birds and the farm birds. And they have the different, it would classify the animals in these three different categories. They are like the linking factor for the transmission of this disease that didn't happen before, but now their behavior has been modified. Other species, as I mentioned before, recently in bovines, in some cases in humans, very few because it hasn't raised a big alarm on the sustainability of the transmissions from human being to human being, but that is are still under investigation. The species that have been mostly affected, as I mentioned before, has been the skunks, the pork or seals, but also historic and the bison in Europe. But historically, the pigs or porks has been highly involved in the rotation of the virus. We have seen some cases in dogs, cats, and foxes. And now, what is this disease and what is it composed from? Well, we all know, right, that This is the neuraminidasas are the most important, but it's important to know this component as well from the virus to better understand its capacity as Virginius. Next slide, please. Very important, their antigenic variations, right, due to variations and genetic combinations, having in its service the nano-DSS, and the most important being two types, right? We have the cytogenes, which is the antigenic derivation, which is the virus of the same subtype, can sort of dismantle and sort of reconfigure itself within the cell, causing some antigenic conditions that makes this virus change and modify itself. But the most important one then from the zoonotic point of view and genetic changes, it's a different virus can combine and they can in general have a different element. They can have the capacity to jump from one species to another. And one of the examples I would say that is more recent, the H1N1 influenza virus from 2009, where we were able to see that the viral gene was completely combined from different origin species. We have North American birds, PB2, PB1 from humans. We have PA from North American birds, and we have HA from North American pigs. And this has multigenic combination that happened from several sources. Next slide, please. Very recently, well, the epidemiology has changed. We used to consider that this low toxigenesis were spreading through wild birds, and when these wild birds will meet with farm birds or domestic birds, that's when the mutation would happen, and then we then this would spread and propagate through the population of farm birds. And then recently we have come to understand that the same as the H5N1 virus, this is spreading this high pathogenesis. A virus has been moving through wild birds, yes, and they are capable of carrying the virus for a long period, yes, for a long period of time, so many kilometers to propagate and continue the propagation. And right now, this could be transmitted by wild means to populations that are both wild of mammals or others, as well as the farm birds as well. When we are looking into the most common processes of fecal to oral contamination, that is the temperature. It can be controlled with a temperature or ultraviolet light, and then it's a high survival of the virus. It has an incubation of about 3 days, but it can have a delay of up to 14 days, and the birds in entire flocks. And then we have other factors such as the sales of birds. That's why it's very important to get to know the epidemiology so that we can prevent its spreading. Next slide, please. Differentiation of the virus from high and low pathogenesis. There's been very few cases, but there are reports of a high pathogenesis virus that are migrating into humans. But this but higher potential are the virus that have high pathogenesis due to the site of their infections and the receptors that they have in the disease, and because of those sites that are monobasic or low pathogenesis viruses, then they can be replicated and is restricted to the respiratory and gastrointestinal sections, while the high pathogenesis virus, because their activation is polybasic, then this can be applied systematically, and then this can go into severe and fatal conditions. Next slide, please.
La tendencia estacional en la incidencia mundial de influenza
The
aviar
seasonal influence
a la 11
in the 1 ABP when demonstrated now, the two different
tendencias, una
trends, one in the northern trend and the other one in the northern
gráficas
hemisphere and the other one
que
in the southern
va a ser un
hemisphere.
poco
As we can see in the graph,
en el hemisferio norte.
they tend to be somewhat different. In the northern hemisphere, mainly in January, there's an increase that begins in October, while in the southern hemisphere,
Correspondiente
there
al
is a
pico.
small peak somewhere
Luego la
in February,
propagación
which
comenzó
is
a
the
aumentar nuevamente en julio y alcanzó un
peak
más alto,
and it started
correspondiendo a los picos de Sudáfrica. Entonces, esto
reaching a
también
higher
es importante conocer para ver las tendencias.
peak in September. It is also important to know for the trend
Se conoce que la influenza aviar es
in which it is known that the avian
y
flu, the seasonal flu,
implementar, digamos, todas estas
to be able
medidas
to implement the cautionary measures
justamente
and to maintain them. But precisely,
para poner más atención en
the
los movimientos, digamos, de las
trend
aves migratorias.
allow us to pay more attention to the movement of the advances and in what moment it has the illness has presented.
Entrando un poco
Okay,
ya
next one, please.
en la situación, digamos, de la región, de por
Going a little bit more into the
uno
situation of the
principalmente
region
por las rutas propagadas
for
migratorias de
the
aves silvestres,
H5N1
de las Américas,
because of the
de diciembre de
migratory
2022
routes of the wild birds in the region of the Americas for data taken from August the 20th, from December 2022 to August 2023, looking at the avian flu, the way that it has advanced in this manner, and coming to
libres o que
countries
nunca habían
that
presentado
historically
casos de
had been immune or that had never presented a case
en aves comerciales o aves
of
de corral.
avian flu
Siguiente.
or production birds. Next one, please.
Ya enfocándonos principalmente en la región del
Now
Oirsa,
focusing mainly on
como ya
the Orissa region,
anterior explicaron,
just like the previous presentation.
y como
What is the steps?
país miembro,
What is the situation
pudimos tener algunos
in Mexico? We were able to have some case.
2022 y 2023
We
principalmente.
had some case between 2022 and
Honduras,
2023,
Rica,
especially
Panamá, fueron los países,
Honduras, Costa
Guatemala,
Rica,
las silvestres también, fueron de los países
Guatemala also. These were some of the countries that were affected
de influenza aviar. Siguiente.
during this time.
Entrando puntualmente, digamos, a los casos que se presentaron en cada país,
Going very punctually into the cases that presented in each one of the countries. Panama, which was the first country that reported in the Oaxaca region.
H5N1
The
se
high
presentó en diciembre del 22
pathogenicity
a abril del
virus.
en este periodo de tiempo se reportaron 7 brotes en aves acuáticas silvestres, principalmente
presented in April 2023.
15 casos,
They
12
had
muertes y
basically
en
some tropical. They had 15
cerca
cases, 12 deaths, and 3 sacrifices in the Gulf of Panama, as well as close to the area of the port of Bacamonte
se tuvo
in the
3
western Panama and others. There were also 3 outbreaks in
casos, 7
backyard birds of 30 cases, 7 dead, and 1,474 sacrificed. All the outbreaks were closed thanks to the actions implemented by the Veterinary Control of Panama,
no se propagó,
and
digamos, a aves
it did not
comerciales.
extend to commercial, and it was able to take it to coral birds also. Next one.
En Honduras también se presentó a finales de diciembre del 2022.
Honduras, it also presented at the end of December 2022. The cases were closed in February of 2023, where there were 4 outbreaks in wild birds, in pelicans, with 325 cases, 210 deaths, and 115 sacrifices. All the outbreaks were also closed successfully. Next one, please. In Costa Rica, from January 2023 to February 2023, they also had 5 outbreaks in wild birds, also with pelicans. In the South Caribbean, 8 cases, 6 deaths, and 2 sacrifices. 1 outbreak in domestic birds in a natural park in Punta Arenas. 60 cases, 60 dead, and 2 sacrifices. All the outbreaks were also closed there. By identifying it, by veterinary services acted accordingly. Next one, please.
solo brote en
The case
abril
of Guatemala, it was one single outbreak in wild birds.
muertes.
They detected 11 cases in Estabal, 11 deaths, and
El virus no se
the outbreak was
detectó
closed. In that case, the virus was not detected in any transfer or any other species.
de enero a abril del 2023.
And that was from
México, como
January to
ya
February 2023.
vea,
In Mexico, as it has been mentioned already, I'm not going to talk about this again, but just to mention that we identified the virus for the first time, and the last focus was H5N1, and the last outbreak was here. And the outbreaks have been detected with a total of 71 cases. Going a little bit more into the matter, which is something more regional, that was executed. As you saw, all these cases, the majority were present in pelicans, and we have the hypothesis that the coastal pelicans also feed from smaller birds, and that's maybe why they were so much affected. They are not birds
de
that
grandes distancias, por lo tanto también
the
eso
migratory birds that fly long distances. So therefore,
se
that is also that might contributed for the illness that to be concentrated and contained
no
in
se
those zones, and not to affect, not to have it extended
sectores
to other
avícolas.
sectors,
Sin embargo,
other
también podría tener
bird sectors.
los climas, ¿verdad?
But nevertheless, there might be something that has to do with weather, very tropical and high
En general,
temperatures that
y que eso también podría
always
hacer que
are implemented there. That is also something that might have had much
pudo haber
favorable
contribuido
environment to be able to control it, and therefore that might be something that might contribute to the infestation of the
pero también al
pelicans,
mismo tiempo porque se
and
pudo
also at the same time because that also allowed a better control, maybe. Okay, next one. Within the actions of ORISA has an emergency fund for the countries. It has regional and national funds. These funds are accessible to the countries through emergency declarations.
Una emergencia por una enfermedad en salud animal, pues pueden acceder a los fondos regionales y si un país declara
Whenever they declare
territorio nacional, puede acceder a estos fondos también nacionales. Estos fondos
emergency
limitados
origin.
y
This is based on contributions, but
digamos de parte del OIRSA, pero para
the resources on behalf of ORISA, but
se activaron los fondos extraordinarios regionales para prevención
during the emergency, there was a extraordinary budget regionally activated for the control and prevention of the avian flu. This
contribuyó a la elaboración de planes nacionales y su presupuesto para
contributed to the execution of national plans and the budget to be able to participate in prevention. There was a national communication campaign regionally that was done for early detection and for the strengthening of the labs at animal control. And
ese miembro de
this
OIRSA por un
was
monto
also done in Guatemala and Panama for the country
479
members of
millones.
ORISA for an amount of $479,000.
Adquisición de secuenciador de nueva generación, compra de
Acquisitions, this
y
included
molecular. Digamos que este dinero se repartió entre los 9 países, pero existió este fondo particular para fortalecimiento de estos dos laboratorios estratégicamente para que Guatemala pueda dar el servicio a los países del norte y la Libes, digamos, a los países del sur y República Dominicana de Centroamérica. La implementación de estos secuenciadores, no todos los países cuentan con secuenciadores, la mayoría diagnósticos de influenza aviar, serológicos,
the potential to do so, but they have a PCR and others with a viral, but they don't have the capability of justifying these viruses, having to send this to external reference labs to be able to carry out all the tests. There is also the technical commission for avian healthy or security, and this is also activated in the public sector by representatives of the sectors of the countries, at least one, and the heads of the programs of avian safety. And this have to provide technical criteria for the control of hyperpathogenic illnesses and for the emergency. This is commission that meets twice a year. We're going to have the next meeting now in the month of July, and we pretend to discuss and give continuity to topics related to what was discussed last year, which was to
y
unify
establecer las
criteria for
directrices para procurar no restringir el comercio. Promover también la actualización y capacitación
surveillance.
para la prevención, control y erradicación de enfermedades aviares prioritarias en la región integrada en el enfoque de una salud. Bien. También estamos con un proyecto de implementación de un programa regional para la detección, prevención y control de zoonosis respiratorias en Centroamérica y República Dominicana, con énfasis en influenza aviar. Estos son fondos del CDC, ejecutado por Secomista, que es la Secretaría del SICA de los ministros de dentro de este proyecto tenemos ejecutamos ya
within this project we have
de una salud, que fue una consulta regional
already
fortalecimiento
regional
de
workshop
sectorial en
for
interfaz humano-animal medio ambiente.
animal health. That was our intersectorial work for the human interface animals and environment. And in El Salvador, we were able to integrate a representative of animal health, of health and human health,
Oficiales de cada país, de los 9 países de
and the
la región
environments from the official institutions of the 9 countries of the OIRSA country, so that we might carry out a consultation among all the countries and all the sectors, and to be able to establish a strategy for the health and prevention and control of these illnesses. We have also had a lot of virtual
diagnóstico del laboratorio de
regional
influenza aviar. Se ejecutó en el Larsa de Guatemala. Se capacitaron.
We have done this with in Guatemala. They trained at least 2 lab technicians out of the 9 countries, and we were supported with all the experience that to be able to give a training both for serology as well as and this is done on the system of animal surveillance. And it is a platform where we pretend to register, record, and analyze the epidemiological issues of the field with the attention of outbreaks and suspicions. But it is something that is going to use for all the illnesses of animal origin. And we leave a small human factor so that we can also record all the cases that are attended with wildlife
que se pueda compartir entre las
so generate a report
que son las
that might
rectoras
be
de esta
shared between the different institutions that are the guiding entities
para la
for
prevención de
these areas. There has also been
vigilancia epidemiológica de influenza aviar y gestión de emergencias que prontamente va
for the
en el
epidemiological
aula virtual de
surveillance, the case of the management of emergencies, and that is also done in the plan of ORIXA. And there has been a new listing carried out of the IAP, and we deliver inputs for the surveillance and diagnosis in the countries of Central America and the Dominican Republic. Next one, please.
realizadas por el OIRSA durante, digamos, las emergencias.
Other actions that have been carried out by ORIXA.
Desde
In view
la
of the emergency,
prevención,
we have always been working from the prevention and surveillance, if it is possible, to have a list of the illnesses that might affect the animals. But through regional alerts, for example, there is preventive coordinations for the countries precisely when we are in the seasonal time in which there's an increase in the cases. Well, we also increase the recommendations and the alert for the countries that do not have the cases, how they can implement actions for the early detection in the countries that they have that for the control. Activation of emergency funds for the advisory and the working plan. Missions, technical missions for companionship to the countries to present cases during the year 2022-23. An evaluation of the sanitary measures that were applied, including the possible use of vaccines. In some of the countries, they are evaluating
si es necesaria la aplicación de vacuna y también colaboramos
if
con
it is
las
necessary the application of vaccines.
seguir las
And
mejores
also we have collaborated with technical assistance to continue on with and follow the recommendations that are made. Currently, the 5 countries that use vaccine are Guatemala, El Salvador, and the rest of the countries of the Central American region are not using vaccines. Support in the elaboration of national and regional drills, the management of projects for the prevention of in preparation to the soil technical information system. This is a project that is in multi-organisms with the participation of the FAO, SICA, the CDC or IRSA, and other participants. Participation in national roundtables and regional roundtables, One Health for the boarding of the IA, and the improvement of quarantine services in all the countries, non-inspective in all the countries of the region. And also distribution of dissemination materials, projects, videos, pamphlets, and to identify suspicious cases in social networks or in different means of communications. We also have supporting material for the control of illnesses. This is at the disposition of the countries. The regional manual for good practice of the management of sanitary emergency, a manual for the operation of animals, a manual for the operation and disposition, biosafety disposal of animals, and the manual for cleaning and disinfection of and animal health. This is available in RISA so that all the countries that are associated might have this and put it into their data banks. The next one, we have identified and with the regional technical commission, AVR commission that I mentioned before, they have identified that the countries of Central America, due to the fact that there have not been cases avian flu in many years, and in some of the countries they had never had that illness, it was detected that they didn't have the technical capacity, sufficient technical capacity to avoid the mortality, that this included the sacrifice, disposition of the corpses, the use of biosecurity equipment, and this, well, we organized the workshop that was carried out in February, where we had the participation of all the countries of the region for the strengthening of this data. This was done in presence, and some practices, field practices were carried out. And also, we have worked with El Salvador as a pilot project for the risk analysis of avian flu in El Salvador, using epidemiological model of pathogenicity that is used for establishing what are the zones of risk, depending on where there have been more sightings of wildlife or migrating birds, so that we can direct the surveillance epidemiological, both the active as well as passive, and better. This is the model that we intend to repeat in other countries that were required or that needed, but these are part of the actions that for the moment have been carried out by the ORISA. And maybe as a last message, just to, on behalf of ORISA, the approach is to do it, but now, nevertheless, we are now integrating this for better health. I have always liked to comment that none of the illnesses we can do it's terrible if we can prevent and avoid it in animals, and therefore from the foxhole of ORISA, we focus on preventing, controlling the avian flu,
para evitar que esta pueda
which is of high pathogenicity, so that this way we can avoid that this might jump onto humans. Thank you very much.
Señor Avendaño, su correo en la primera lámina es correcta, dice ORISA.
Your slide, your email is correct in the first slide. Is that correct? Yes, it's avendaño@orisa.org. That is my email.
So just so you know, we don't introduce every speaker. All the bios are in the chat and in the document that is part of the agenda. So you can read up on each speaker and know their backgrounds and who they are. We want to favor more time for presentations and favor more time for dialogue and chats and questions. So we're about 10 minutes behind. What we're going to do is reduce the dialogue time though just before lunch. So I really appreciate Mr. Avendaño's regional perspective. They're quite strong in Central America and Dominican Republic, so it was good to have that perspective for us, given our northern region theme of the workshop. I'd like to now invite, we have two speakers left before lunch. And so the next one will be from the USDA, Dr. David Suarez. Over to you.
All right, thank you. All right. Yeah, so I appreciate the opportunity. I'm with the U.S. National Poultry Research Center in Athens, Georgia, oftentimes known as the Southeast Poultry Research Laboratory. And I wanted to provide some research that we've been doing, a little bit different subject. This is actually going to be talking primarily about California condors. I actually will have a few slides at the end that talks about the dairy outbreak, because I know that's of interest to many people in the room. Next slide, please. So again, I won't provide any more introduction in influenza. Obviously, the hemagglutinin and neuraminidase are very important for the virus to infect animals, and the hemagglutinin is the most important gene as far as virulence, making viruses highly pathogenic. Next slide, please. And of course, the lineage that we're really have been concerned about, and the one with both the condors and the California and the dairy cattle, is this goose Guangdong lineage of highly pathogenic avian influenza. This lineage started as early as 1996 in China. It has since become global. It's been found basically in every region of the world except Australia. And so it has certainly been, over the last 20 years, probably the biggest poultry animal health issue that we've dealt with worldwide. Next slide, please. So the current outbreak, just a little brief update about what's happening in the US, of course, is that it was first detected, the 2344B virus was first detected in Canada in December of 2021. It was shortly found in the US after that in hunter-killed ducks. And then about a month later, in February 8th of 2022, we had our first commercial outbreak. Since then, the virus has become widespread in the US in wild birds, and we've had many direct inoculations or transmissions of virus from wild birds to commercial poultry. Overall, the number of commercial poultry operations were almost at over 1,100 commercial poultry operations have been infected, involving 49 states, either backyard or commercial poultry, and then again, a number of wild bird detections. So the virus is endemic, looks to be endemic in the wild bird population in North America, probably, and may also be endemic in South American countries as well. And again, the overall impact is that we've had to either euthanize or animals have died. Over 96 million birds have been affected in the US alone. And of course, those numbers would be higher if you added Canada, Mexico, and the other South American countries. Next slide, please. Now, one of the key things to remember with this virus is that there's some genes that have been found in all these viruses, and these 2344B viruses, but we also see a lot of gene reassortment, and primarily it's the polymerase genes and the nucleoprotein have swapped out, and so we see different variants. Now, can this affect the ability of the virus to infect and cause disease in different species? I mean, the answer is probably yes, but for most cases, we don't really see differences, at least in chickens and turkeys, that all the viruses that have the virulent hemagglutinin gene, the H5, has been highly pathogenic when we tested it in the laboratory. We don't see very many differences in its ability to infect or transmit, at least in the laboratory. Now, some of these differences may, again, play more important roles, and that really isn't the subject of my talk today. Next slide, please. So why are we talking about California condors? And obviously it's because H5N1 has caused a significant outbreak, and this is kind of the response to that. Let me just give you a little bit of background about California condors. Obviously, it's an endangered species. It's a New World vulture, and it's actually the largest land bird in North America. It became extinct in nature, meaning that all the wild birds actually were caught and brought into captivity in 1987 because the numbers had dropped so low. It had gotten down to there was only 27 birds left alive. And so the decision was made to try to do a captive breeding program to increase the number of birds with the goal of reintroducing these birds into the wild. And that's what happened 10 years later. Now, currently, there's estimated to be 561 total birds, so still a very highly endangered population, but improving. Next slide, please. And this just shows the current range. So it is primarily, obviously, California, based on the name, is primarily part of its range. But we also can see in the U.S. That we have it in the states of Utah, Arizona, and Nevada. And there's actually a range in Mexico as well. So there are wild condors found in Mexico as well. Next slide, please. Now, the decline of condors is for many different reasons. Some of them are that condors are carrying, eating birds, so they're eating dead animals. And because of that, lead poisoning has been a serious and ongoing problem. And there's actually programs to try to mitigate the lead toxicity that we see even in the birds that have been released. Habitat loss has been an issue. And then agricultural chemicals, DDT, even though that's been banned for many years in the U.S., was obviously at this point contributing to the loss of the birds. And poaching was also a concern for the decline of the species. In the spring of 2023, we had an outbreak of highly pathogenic avian influenza in condors, again, probably because they were scavenging birds or ducks that had died of the infection. And we had at least 21 birds known to be infected with the virus, and 17 of those birds died. So again, when we consider there's only a little more than 500 birds, that was a 5% loss of the entire population in one event. And because of the severity and obviously the high impact of this outbreak, the U.S. Fish and Wildlife Service was looking for ways to, could they mitigate this in the wild bird population? And so the decision or the request was made is, could we use vaccination as a control tool? Next slide, please. So the Fish and Wildlife Service reached out to the USDA, and part of the first thing we did was we looked at what vaccines are actually licensed in the U.S. that could potentially play a role that we could use for vaccination. When we looked at the live vectored vaccines, we have both the HVT vectored vaccines and the fowlpox vectored vaccines are licensed, but both were decided probably were not good choices in this case. First is these viruses are very species specific, meaning that they'll only replicate and provide an immune response in a limited number of species, obviously chickens and turkeys. And condors were unlikely to get a good immune response. And then the second one was just the risk of using a live vaccine was considered too high. The risk of an adverse effect causing, obviously, killing birds was just considered to be too high. Now, we also have an RNA particle vaccine that was considered. This RNA particle vaccine has some of the characteristics of a live vaccine, but it doesn't replicate. So it felt it was like it was going to be relatively safe. But since we had very little data in birds, it had been tested in chickens and turkeys, but not in other species. So again, the idea or the thought process was that it was going to be too risky for use in condors. So finally, that came down to really the only other option that we had available to us was to use a killed whole virus vaccine. And we had one that was made by Reverse Genetics that was available. That was pretty close. It was 95% similar to what was circulating. It was actually based on the 2344C virus that had circulated in the US in 2014-15. Next slide, please. So why would this be a potentially a good vaccine? And of course, these vaccines, because they're killed, we don't have to worry about any reversion to virulence of the vaccine. We've actually have a number of different killed vaccines that we've used in the past using both low virulent viruses, reverse genetics viruses, which are a low virulent virus, and even in some countries like Indonesia have used highly virulent or highly pathogenic avian influenza as part of their vaccines. And there's also were studies done with similar vaccines that have been done in zoo birds, primarily in Europe. With generally the birds, although not all the birds responded well to the vaccine, there wasn't any adverse reactions to the vaccine in those zoo birds that was at least in the published studies. Now, the killed adjuvanted vaccines generally produce good antibody levels in poultry and are generally considered safe. Obviously, they're used in billions of doses a year in poultry, and generally there's not a large safety concern. Now, because again, condors were an endangered species, that there was concern about using these vaccines in condors because there was no previous studies of similar type vaccines being used in condors. So the idea was proposed to actually look at a closely related species, which are black vultures. Next slide, please. Now, of the New World vultures, there's 3 New World vultures, and we have that, obviously the condor, the black vulture, and the turkey vulture. Black vultures in the U.S. are actually very common. In some cases, they actually are considered a nuisance bird. And there was actually, in this case, we were able to get some birds that were considered nuisance birds that were going to be depopulated anyway, and those birds were caught and brought into the laboratory or into a field site to do studies. And the vaccine, the study design was just to vaccinate with either a single dose of the vaccine or a 2-dose regimen separated 3 weeks apart, given subcutaneously, and then just monitor for serum antibody response and observe for any vaccine reaction. There was never a plan to try to challenge the vultures in this study that we felt based on the studies that we've done previously in poultry and chickens and turkeys, that if they develop an antibody response, we feel confident that that would be protective in black vultures as well. Next slide, please. Now, when we looked at this response, and you can see in the light gray bar was a single dose response, and that most of the birds did respond to the vaccine, and unsurprisingly, given 2 doses of vaccine, we saw a better immune response and a longer lasting immune response as compared to a single dose of the vaccine. Now, the titers, even with the 2 doses of vaccine, the HI titers were at most around 200, which are not very high, particularly compared to chickens or turkeys that would be vaccinated with the 2-dose approach like this. And part of this, we believe, of course, is that the adjuvants that we use was a vaccine that was originally designed for use in chickens, and therefore it was optimized in that species. And so it is not surprising that we saw a decreased titer compared to chickens because it wasn't optimized in condors or vultures in this case. And that is not, again, an unexpected finding. But we did feel like these numbers, and anytime we see antibody titers, HI titers above 40, we generally consider that to be that it would be protective in those birds if challenged. And so we felt these numbers were good. That we still have questions about how long the antibody response will last, but at least we felt comfortable with this study. Next slide, please. So we didn't see any adverse reactions to vaccination in the black vultures. Again, almost all the birds had a serologic response. And we did see, again, higher titers with 2 doses of vaccine. Now, again, based on this black vulture study, we did feel like there was good data to support us going into condors, and that study was also initiated. Next slide, please. And this is just showing vaccination in one of these condors. So again, it was given subcutaneously in the leg. And it obviously takes a very large group of people to handle these birds because they are so large. Next slide, please. Now, if you look at the condor titers that we have, again, that we did see a better response with 2 doses, but we did not see as good of a response in condors as we did in the black vultures. And so, it is a question, again, with the titers of, 20 to 30, is that going to be protective of these birds in the field? And honestly, we don't know for certain if they were challenged, how protected they would be. You have to be concerned, of course, that because of the small number of individuals, there has been a genetic bottleneck. That potentially is part of the reason why they didn't respond as well as the vultures did. And also, many of these birds have been exposed to lead. There are opportunities to actually recapture free-living wild condors and bring them in, and they will actually do treatments for the lead because that is still an ongoing issue with these birds, and lead certainly can decrease the immune response, and so that may also be part of the issue. Next slide, please. So again, the antibody response is lower than observed in black vultures. We did see issues in a few of the birds where we did see granulomas at the site of inoculation. Granulomas, particularly related to these oil adjuvanted vaccines, have been seen in other species. Again, we did not see any of those in the black vultures, and it may have been we just didn't inoculate enough of the birds. And that is a concern. But again, in this case, the risk of exposure to high-path AI in the field felt that that was a bigger concern, and so they are continuing with the vaccination program. Will this be enough protection in the field? You know, it's unclear, but I think the idea that at least some of the birds did survive with no previous exposure, at least that we know of, that if we give them some immune response, the idea or hope is that they will, again, have at least some protection that they can survive if exposed to the virus. Now, all the condors are tagged in the wild, so all the vaccinated birds will be monitored. And as I had mentioned, they do try to capture these birds each year to look for lead toxicity and give them treatment for that. And so there is opportunities to continue to vaccinate these birds in the future. Fortunately, there have been no new outbreaks have been reported. And so hopefully that will continue to be the case. But again, and I'll just kind of finish up that this is the first time in the U.S. that we have actually vaccinated for highly pathogenic avian influenza in the field. Obviously, there was a lot of concern about trade partners looking at this as that the U.S. is vaccinating, but it was in a very limited and controlled setting. And again, part of the reason why I think it was accepted by trade partners is that, again, all the condors are tagged and we continue to monitor them after the fact. Next slide, please. So now, and this is my acknowledgement slide, there's a huge group of individuals that were involved with this project, including from the U.S. Fish and Wildlife Service, the state veterinarians in California, in North Carolina. Zoetis was the company that provided the vaccine for these studies. All the vulture studies were done at the Carolina Raptor Center, and then there's been a large group of people from the zoos and from the Animal Plant Health Inspection Service that this study could not have been possible without their help. All right, let me switch over to the dairy outbreak real briefly. Next slide, please. So next slide. So again, the previous slide said high-path AI in dairy and other mammals. And if you hadn't been aware, we've actually had quite a number of detections of high-path avian influenza in species, particularly species that are eating carrion. So a lot of foxes, bobcats, mountain lions, black bears, mink and fisher have all been exposed or have been detected of having high-path avian influenza. And when we look at the viruses generally are very different in each of these. Again, I mentioned previously the having different genotypes, internal genes in some of these genes. And that's what we're seeing, that we don't see a single virus that's infecting all these species. It's a bunch of different viruses with different internal gene cassettes. Next slide, please. Now, obviously, we had not had any outbreaks in dairy cattle or cattle at all. And unfortunately, we had an outbreak that the virus was detected in high amounts in milk. And this is actually the slide showing at this point, we actually have 12 different states with at least one known dairy farm with infected animals. The first detections were in Texas back in March of 2024, so just 2.5 months ago. Movement of animals does look like it was a very important part of moving this virus to different states. All the virus to this point looks to be very genetically similar. So it is actually the same genotype for all these different viruses. It looks like it was probably introduced just a single time into dairy cattle. And then unfortunately the virus was moved before it was clear what was actually causing the outbreak of mastitis in these animals. Next slide, please. So the clinical signs that were observed was we did see asymptomatically drops in milk. Sometimes it was asymptomatic, so we didn't see any disease symptoms, but drops in milk production, poor milk quality, reduced appetite, clinical mastitis, and nasal discharge were observed in the animals that did have clinical disease. The virus could be as high as 10 to the 10th egg infectious dose 50s in milk, which is just an incredibly large amount of virus. Now understand that the animals that had these high levels of virus, the milk was visibly affected, and none of this milk should have gone into the human supply, because that is, standard that when you have cases of milk of poor quality, it should not be going into human consumption. Viral RNA could be detected for up to 31 days in these infected animals, although in many cases, as the infection progressed, we could detect by viral PCR, or by PCR, we could detect viral RNA. We could not see any live virus in those animals. Cattle do develop a serologic response, again, which is thought to mitigate the infection. We do believe that antibody in the milk is causing the virus to be inactivated. The cows usually recover and start producing regular amounts of milk, although full production may not return for at least that cycle, and we don't know what's going to happen in future cycles if those cattle are calved again. Next slide, please. So this is actually showing you some milk from some of these infected animals, and you can see that the milk is both discolored and actually that you see that the milk is coagulating, and so you're seeing large chunks. Obviously, none of this milk should have been put in the commercial supply, because it is obviously greatly, does not look normal, and it should have been thrown out. Next slide, please. So I do like to point out that when we went back into the literature, back actually into the 1950s, the Canadians actually did a number of different studies that looked to see whether influenza, in this case it was a human influenza virus, could infect, could grow in a cow's udder. And they actually put in an influenza virus and a Newcastle disease virus, and both of those viruses were able to replicate in that tissue, in the mammary gland of that tissue. They could get a productive infection, measurable amounts of virus for up to 14 days. And these cows did not have any reported illness. Coats were also tested with similar results. Next slide, please. So our part of the research is when the outbreak occurred, there was a big question, certainly, was milk safe? And so one of the first things that we did was we did a retail milk testing in collaboration with the Food and Drug Administration, which monitors milk in the United States. And so we looked at a total of 297 samples, primarily from states that were known to have infected dairy. So the 20% is not representative of what was happening around the US, because it was a targeted selection of samples. And we looked at a number of different types of milk and dairy products. And again, 20% of those were positive. When we did PCR to measure what the mean titer equivalents were, we generally saw 2 to 3 logs of virus in these samples. But when we did virus isolation, we could not detect any virus in any of these samples, meaning that the virus that we were detecting was not live virus. It was probably just viral RNA. And it does look like pasteurization is doing a good job of inactivating the virus. Next slide, please. We also looked at a hamburger study. There was, of course, a concern about, well, if it's in dairy cattle, could it be in meat? And there was at least one report that in a condemned animal at a slaughter plant, they were able to detect virus by PCR. It's unclear whether that was live virus or not. And so we ended up working with our sister laboratory, actually did a study, wood cooking hamburger meat, where it's more likely that you would see animals coming from dairies being put into hamburger. We cooked it at 3 different temperatures, and then we looked at it by PCR and virus isolation to see if the virus was inactivated in those samples. And it turns out that at the 2 higher temperatures, 145 and 160 degrees, the virus was completely inactivated. Now, 160 degrees Fahrenheit is the recommended time or the temperature that you want to heat hamburger to kill other pathogens, including salmonella. And so this is, if you cook the hamburger meat correctly, there should be no concern about highly pathogenic avian influenza, even if it was in the samples. And again, we don't really have any examples of the virus being found in retail meat at this time. Now, virus, when heated to 120 degrees Fahrenheit, did not completely inactivate it. It did kill about 2 to 3 logs of virus. We had about 5 logs in the sample, and it killed 2 to 3 logs of that virus. but it did not completely eliminate that virus. And again, cooking to 120 degrees Fahrenheit is a very rare hamburger. It is very red, pink on the inside. You would not want to eat that anyway. Next slide, please. So future work, again, pasteurization studies are ongoing. It's been very difficult to model pasteurization at the bench top because the just small technical details can really affect your results. And so we've actually been working with the FDA using a continuous flow pasteurizer, which is similar to what they use in the field. And currently our testing shows that the common temperature of heating it up to 72 degrees Celsius for 15 seconds does inactivate the virus. And in particular, combine that with homogenization, we do believe that commercial retail milk should be completely safe for human consumption. We're also testing lateral flow assays, which are those point of care tests in milk and at the dairy cow level. And they do seem to have some value. Those tests are not very sensitive, but they do detect this particular virus and could be a good way to screen animals in the field. Future tests will be looking at vaccines for the control of infection. There's a lot of interest in whether we should vaccinate cattle and other small ruminants for this virus because of the potential for human infection. Next slide, or the last slide. Actually, so I don't really have any additional works on this. I'm sure there'll be some questions in the discussion. I will be happy to answer them at that point. Thank you.
Thanks, Dr. Suarez. That was great. I think there's a lot of press interest in the second half of your presentation. I suspect, at least in Canada, where I'm from, probably the single agriculture issue, or food issue, that gets the most press attention is always food safety. So, your work is timely and very helpful to help explain through science to the general public to reassure them. So I will ask you to come back in the next half hour. We're going to have all the morning panelists come on the screen and for a Q&A session. Right now, I'd like to invite Dr. Oliver Lung from the CFIA, which is the CFIA in English is Canadian Food Inspection Agency. Over to you, Oliver.
Okay, thank you. Just want to check to make sure that you can see my slide.
We can see it, but it's not in presentation mode.
Okay. Okay, good morning, everyone. Thank you for the opportunity to tell you about some of our activities on optimizing genomics and bioinformatics when we are dealing with large amounts of samples, such as the pandemic and HPAI outbreaks. So at the start, I will briefly introduce the Canadian Food Inspection Agency National Center for Animal Disease. We're based in Winnipeg, Manitoba, and we provide scientific and laboratory services for the identification and reporting of emerging and high consequence animal diseases like foot and mouth disease, high-path AI, African swine fever, and so forth. And we operate containment level 2, 3, and 4 laboratories. And we house a variety of different World Organization for Animal Health reference laboratory, such as for avian influenza, African swine fever, and we have our sister lab in Lethbridge, Alberta, that our reference lab for anthrax, BSE, and bovine viral diarrhea. And we also house FAO reference centers for foot and mouth disease and other vesicular diseases, as well as for zoonotic and emerging pathogens. So the genomics unit at CFN-CFAD was established in late 2016, and we operate high throughput sequencing labs in both containment level 2 and level 3 that allow us to sequence samples conveniently that are coming out of containment level 3 and 4 labs. And we provide genomics and bioinformatics support for diagnostics, surveillance, as well as research activities. And each year we sequence and analyze thousands of diverse Canadian and international samples with known and unknown pathogens. And in the past few years, we've been fortunate to be able to update our sequencing capacity with new technology over the past few years. So this slide summarizes some of the diverse samples that we sequence at NCFAD. We sequence a lot of viruses like influenza A virus, SARS-CoV-2 virus, foot and mouth disease virus, but we also sequence a lot of other targets that may be viruses not listed here, or bacterial pathogens or other types of targets. And that actually represents quite a bit of the samples that we deal with. Just an example of some of the genomics investigations we are involved in. We've contributed to border security, where we have sequenced samples that are confiscated at the Toronto International Airport from passengers arriving internationally. And we found genetic sequences related to Newcastle disease, vesicular stomatitis, and so forth in these confiscated material. We've also been involved in many different wildlife and farm case investigations that may contain novel or unexpected pathogens, either from farmed animals, from terrestrial or marine wildlife. And as part of these activities, we've identified several new viral species in the past few years. So since our formation, the number of samples that we process for high throughput sequencing and conduct analysis have increased substantially. And prior to 2022, the predominant sequencer that we use are from Illumina, shown here in blue. But starting from 2022, Nanopore has become the main sequencer that we have been using. Nanopore currently represents about 65 to 70%. Influenza actually represents about 65 to 70% of our sequencing samples. So in order to deal with the large amounts of samples and large amounts of data that we have to process for high throughput sequencing, we've been automating our sample to results workflow to improve our efficiency, reproducibility, and scalability. For example, on the wet lab side of things, a lot of our sequencing library preparation are done by liquid handling robots. And we also have deployed an NGS LIMS system called MISO to track our sequencing operations, to manage our sequencing operations of most of the sequencers that we use routinely in the lab. And on the bioinformatics side, we've developed several different automated workflows for dealing with sequence data from Nanopore in a tool we call Verantis. And for Illumina, we have an automated pipeline called Vilumina. And for influenza A and B, we have a dedicated pipeline we developed called NFFlu. And we also adopt other tools that are developed by other researchers. And I'll talk a little bit about some of these automated tools in the next couple of slides. But I think this one is just to sort of highlight some of the things that the MISO LIMS system will do for us. MISO is short for Managing Information for Sequencing Operations. It would automatically scan our sequencers every 15 minutes and allows to have automated data entry into MISO. It also allows us to track projects, samples, and processes in the wet lab, for example, the reagents and the kits that are used for sequencing. And it provides an audit trail of who did what and when. So this has been a really useful tool for us. And this is open source, so we don't actually have to pay licensing fee for it. So for the next couple of slides, I'll talk a little bit about our activities for dealing with SARS-CoV-2 in animals, because this is kind of the one of the changes that really forced us to automate a lot of our bioinformatics and sequencing because of the sample volume that was coming in at the time. And then and this trickled into the avian influenza work, as well as some of the other viruses that we deal with. So the first SARS-CoV-2 virus sequence was published almost just 2 to 3 weeks after the news broke on the mysterious pneumonia disease in China. And so this is very important for the subsequent responses. And there's more than 16 million SARS-CoV-2 sequences in GISAID. A few months ago when we checked the entry. So this slide is meant to kind of give you an idea of how we started dealing with SARS-CoV-2 at the beginning of the pandemic. We evaluated many sequencing methods for whole genome sequencing of SARS-CoV-2 to look at its performance as well as limitations. And we also sequenced all of the virus stocks that we have in the laboratory. So we passaged these SARS-CoV-2 viruses in 2 different viral cell lines. So we sequenced these viruses as they were passaged, but we also sequenced the stocks that were from the Public Health Agency of Canada, the Vaccine and Infectious Disease Organization, which are the precursors to our stocks. So this is how the virus stocks were transferred from one lab to the other. And the first Canadian confirmed case was from Sunnybrook Institute in Toronto. So we sequenced these viruses and we compared the mutations of all our stocks and its predecessor with the Wuhan reference strain. So we know the differences that have occurred in these different viral stocks. And of course, these viral stocks were used to experimentally infect animals. And we sequenced these animals, samples from these animals as well. And we've also been involved in sequencing samples from companion and captured animals, as well as mink farm outbreaks in British Columbia and Western Canada. For the next couple of slides, I'll talk a little bit about our wildlife surveillance work, which is still ongoing. We're still sequencing SARS-CoV-2 while we're handling the high-path AI sequencing. And most of the data is from white-tailed deer. So this is an example of an automated human readable report that summarizes our bioinformatics results. And so it contains a lot of very useful information like summary stats as well as QC quality control metrics. So for every sample that we sequence, we have information like the percent genome coverage, the total number of reads per sample, as well as number of reads that map to SARS-CoV-2, as well as positions and the location of nucleotides where there are insufficient depth of coverage. So they haven't been sequenced enough times, indicating that their nucleotide base call may not be very accurate. It also contains a lot of variant calling information. So every sample, every mutation that is different from the Wuhan 1 reference strain is reported. And in cases where there are alternate allele, like major and minor variants, those minor variants are also reported, as well as the ratio of the major and minor variant, as well as the impact of the mutation, whether it affects the amino acid of an encoded protein. And so these are all provided in the report. The report also contains information like lineage, as well as other types of information. And this is another tool that we developed for SARS-CoV-2 that allows us to interactively visualize depth of coverage alongside variant calling information, so the mutations that we observe, as well as other genetic features. And here at the bottom is the schematic of the genome of the SARS-CoV-2 virus. 5' UTR is on the left end, and then 3' UTR is on the right end, and then this is the whole 30 kb genome. And here there are 3 examples of samples where the y-axis is the depth of coverage. So how many times we've sequenced each nucleotide. And then these colored vertical bars are mutations that are different from the Wuhan 1 reference strain. And if you click on any of these bars, it will give you a lot of information on what this mutation is, whether they're minor variants, and whether there's any effect on amino acids being encoded, and so forth. So these kind of bioinformatics tools have been expanded to avian influenza sequencing, as well as a lot of the other viruses that we sequence more routinely. So I'll show a few slides on sort of data. The work is through a very big collaboration with One Health partners across Canada on SARS-CoV-2 surveillance in wildlife, include federal labs, provincial and territorial labs, as well as partners in academia, NGOs, and communities. So this is a phylogenetic tree showing Canadian white-tailed deer labeled in red, and a background of SARS-CoV-2 sequences globally. And what we find is that we see in Canadian white-tailed deer multiple variants of concern, including Omicron, Alpha, Delta, as well as a very diverse lineage called B.1.641. And this suggests that there's multiple independent introductions of SARS-CoV-2 into Canadian white-tailed deer. So the first detection in free living wildlife of SARS-CoV-2 was white-tailed deer in Quebec. And in these samples, we detected the Delta variant. And this is not unexpected because this figure here shows that on the top, the animals were harvested mostly at the end of 2021, when Delta variants were the predominant variant in the Canadian human population. And here on the bottom is when the animals that are actually positive for SARS-CoV-2 were harvested. It's again in November, December in 2021, when it's mostly Delta in the human population. But if we look at Delta variants that we detect in white-tailed deer across Canada, we have an interesting observation. So here, the Canadian white-tailed deer sequences are labeled in red. And on the right are uncommon amino acid mutations. And these uncommon mutations are labeled according to the gene it's found in. So they're color-coded. For example, ORF1A mutations are shown in green. And you can see that from Western Canada, these white-tailed deer have a very different pattern of these uncommon amino acid mutations when compared to white-tailed deer from Eastern Canada. Again, suggesting there's multiple independent introductions. And similarly, for the alpha variants that we detect in white-tailed deer, there's also a lot of distinct mutations, and they're again color-coded according to the genome. And these mutations are not found in other sequences from this same sublineage that are available in the public sequence repositories. Also very interesting, again, is we're detecting alpha in white-tailed deer when the human population is mostly Delta. And alpha is very rarely observed, suggesting there's evolution that's going on in the background that is going on silently. Another interesting observation we made was we detected a very diverse novel lineage, B.1.641, which is shown here at the end of a very long branch. This cluster includes white-tailed deer sequences from Eastern Canada, from Ontario. But there's also one sample that is from a human from Ontario, suggesting there's a deer to human transmission. And if we look at the mutations that are present in these sequences, the top here is the 1.641 clade, so mostly Ontario white-tailed deer with a single human sequence. They share almost all of these genetic markers for this clade. There are a small number of sequences, mostly from mink and humans from Michigan across the border on the US side that are shared with this clade from Ontario white-tailed deer. And there's one very rare mutation. There's the ORF1A mutation that is a 15 nucleotide insertion that was only found in 32 sequences when we did the analysis. And 31 of these 32 are mink from Michigan. And then the 32nd one is the human from Ontario. So it's a very rare mutation that is not very widely seen. And so to further characterize this, we have a group in the lab that is using machine learning to characterize emerging and novel viruses. And recently, Joe Rudar published a paper using genetic signatures within the genome of SARS-CoV-2 and demonstrated that can be used to predict host source. And what his model was also able to do is he was able to identify a new human sequence using the model developed in this project. So these boxes represent sequences from the Ontario clade. You can see the mutations here on the right. And this particular arrow at the bottom represents one human sequence from Michigan that shares a lot of these mutations. Although the insertion that is observed in the sequence is very similar to the one in Ontario white-tailed deer, it's not identical. So I think this is another very interesting, perhaps related to a precursor to the Ontario white-tailed deer clade. So I'm going to switch gears and talk a little bit about experience with the high pathogenicity avian influenza outbreak. But because right after lunch, Dr. Anthony Signor from the CFI will be presenting a lot of details, I will just cover some of our work on trying to optimize the genomics and bioinformatics workflow for high path avian influenza, and also talk a little bit about our observations from all the sequencing that we've done. So since the first case that was reported in November 2021 in Canada till the end of end of May this year, we've sequenced more than 5,200 influenza A viruses, including more than 3,400 H5N1 from Canada. These whole genome sequences are mostly from birds, but we also sequence about 100 mammals, including red fox, skunk, black bear, raccoon, mink, dolphin, and seal. And this is the work of a lot of people. And so I'm just going to acknowledge the people that are involved in this project. And some of the work have already been published. Since our unit's formation in 2017, we've been sequencing influenza. And over the years, the number have increased and the technology have also changed. We are now sequencing mostly with nanopore for avian influenza. This year, 2024, all of the avian influenza sequencing has switched to nanopore. And I'll talk a little bit about the advantages shortly. And influenza currently represents about 65 to 70% of the high throughput sequencing that we perform in terms of samples and also the total runs. So it's more than half of what we sequence. So the main reason that we've switched to nanopore is because the turnaround time for reporting is much faster. And also we can get the influenza genome data cheaper than Illumina. So for comparison, Illumina, we need about a day to generate the library, and then we need another day to run. And then after the end of the run, we start the analysis. And so it takes at least 2 days to generate a report of the sequencing results. But by switching to nanopore, we reduce that from about 2 days to usually about 3 to 4 hours with the results reported. And the main reason for this is for the Oxford nanopore sequencing that we do, we can get sequence data available in real time. So within a few minutes, we can start analyzing the data. And we also have a rapid automated analysis and reporting software tool that we develop so that if we get the samples in late morning, we report the genomic results back in early afternoon. And also because we can reuse the flow cells, the cost savings is substantial, and we can sequence it for about a third of the cost of Illumina currently. So NFFlu is the automated pipeline that we developed that is used for all of our influenza sequence processing. Because it also handles influenza B, it's also used by some of the public health laboratories for human sequences. This is a very easy to use tool. It's a single command. It's also scalable and reproducible. There's no human manipulation. It's all automated. If people are interested, you can take a look at it and try it if you want. It's on our GitHub page shown here. This particular pipeline provides 4 types of reports shown here. Includes the coverage information, the consensus sequence, multi-QC report, as well as a subtyping report. And for sequence comparison, it includes all the publicly available sequences that are available, but we can also specify our own sequences. So currently, I think we have about 20 or so sequences from earlier on in the outbreak, since the outbreaks began, included as a reference. So we can compare every new sequence with representative examples of different genotypes that we sequenced earlier on in the outbreak. So this is mainly similar to what we've done for SARS-CoV-2. We have a lot of QC metrics and useful information for influenza, as well as the interactive display of mutations. One thing that we did add to the NF-flu is a subtyping report, so that for every influenza sample that we sequence, it'll report the subtype prediction, as well as the top matching public sequence for all 8 gene segments. And all of this is reported automatically. It's just a single command. And so this is a very, very fast and scalable report that saves a lot of time. And this is just an example of some of the data we have from the avian influenza surveillance activity from about 1,800 Canadian avian surveillance samples. We observed we observed 56 different HN subtypes. So you can see here, there's a lot of different subtypes that we observe that are out in the field. And some of these are more abundant than others, but I think these are used for information. So in the next few slides, I will briefly talk about some of the initial observations from sequencing the HPAI samples. So we got our first case just before Christmas in 2021. It's from St. John's, Newfoundland. And the first case is Eurasian lineage. All 8 segments are most similar to H5N1 from Europe, especially one sample from Netherlands. In the next couple of weeks, it's still Eurasian, but we do see more and more single nucleotide polymorphism. So there's more mutations compared to this first case from Newfoundland. But about 4 months later in March, we start to see resortments with up to 4 gene segments that are now most similar to North American lineage viruses from wild birds. And so this kind of simplifies what we observed, but just giving you an idea. The first kit we sequenced had 8 blue segments that are Eurasian lineage, but by 4 months later, we see a lot of different genotypes with blue and red gene segments, the red representing North American lineage viruses gene segments that start to appear in our sequencing data. And you'll hear a lot about this, I think, in the next slide, where Anthony will talk about more detailed characterization of these data. And so this is not only happening in birds, but in the wildlife samples, the mammals that we sequence, we also see the various genotypes. So I want to share a few observations that we had. That one is one of the sample received in May 2022. The provincial laboratory that submitted the sample detected as avian influenza matrix positive, but it was negative for H5 and H7 by the subtyping PCR. But when we sequence the whole genome, the genomic data does indicate that it is a H5N1. And so I think the whole genome information is really important for monitoring virus evolution and to ensure that the diagnostic tests are up to date and can detect all the viruses that are being detected in the field. This is an initial observation of how sequencing success correlates with CT values. On the x-axis is the CT value based on the matrix PCR. And then on the y-axis is the number of segments that we can report because it passes our QC. And you can see that as the CT value goes above 25, we see a lot more samples that are missing gene segments or missing or have gaps in the gene segments, so that the sequencing results aren't as good. And our initial observations suggest that when we see gene segments that fail to pass QC, HA and NA have actually a slightly higher percentage of it failing QC. So in addition to dealing with real world samples, we also participate in a lot of international wet and dry lab exercises to make sure that our genomics and bioinformatics methods can tackle challenges that are unexpected. And so we participate in these every year, where we get either blinded samples or we get data sets that we have to analyze and report. So this keeps us sort of challenged with things that may be unusual. And so to summarize, genomics data is critical for tracing the origin, transmission, and evolution of viruses, and to ensure diagnostic tests are up to date. Scalability, reproducibility, cost effectiveness, accuracy, and turnaround time for acquiring the data, as well as analysis and reporting is important. In rapidly evolving situations, we have to be responsive and keep up to date with the latest developments and lab protocols, technology, and software. But we also have to try to maintain quality, accuracy, and reproducibility of results. And as mentioned a few slides ago, we do see a very strong correlation of CT value with the success of sequencing the whole genome of avian influenza virus. And I guess this is not unexpected. So I'd like to acknowledge people in the genomics unit that contributed to the work. Their names are shown here in bold. We have wet lab people that also does the analysis, as well as people that develop software and work on bioinformatics specifically, exclusively. And special thanks to the special pathogens unit and avian disease unit for passing on the samples to us, as well as the large consortium collaborators for the SARS-CoV-2 surveillance and the avian influenza response work that I talked about, as well as the funding from CFIA and also from external funders for operational use. So with that, if you would like to contact me or visit our GitHub page to look at our publicly available tools, yeah, please feel free. Thank you.
Well, thanks, Dr. Lung. Good timing, and we have about 10 minutes left for Q&A questions. And I'd like to invite the room to raise their hands so I can see if there are any questions from the room. And I'd like to invite, because the mic is here next to me, I'd like to, if we can, post all the speakers from this morning on the screen and invite Carlos to come up with me here, please. Carlos, would you like to stand with me? And then just let me know if there's anybody in the room who'd like to ask. En español está bien, pero no se escucha desde allá. Hay que venir hasta acá. Con su pregunta, por favor.
In Spanish is okay, but we can't hear you all the way from there. You have to come here so that the question can be heard on the web.
Gracias. Buenos días, yo soy Luis Lecuna, yo trabajo para la
Good morning, I'm Luis Laguna, and I work for the Office of the Department of the USDA in the United States and Mexico.
Una para
And
cada
I have
uno de los tres
three
primeros
very
expositores.
punctual
Para
questions.
el doctor Carlos, me gustaría
Carlos, I would like to for him to tell us, because it calls my attention that you talked about the presence of the influenza virus in migratory birds. So I don't know if any of the bulletins, have you identified the species of migratory birds that were detected? And what was the variant of the influenza virus that was detected? Being this one of the factors that it demonstrates that a majority is H5N1. And just to confirm it, if it is in one of the bulletins or if it is some other source in which we might be able to obtain that information. To Dr. Nestor
de la
Daño,
importancia de un laboratorio
you
regional.
spoke about the importance of a regional lab in Central America. But I would like to know if you are working jointly in the processes in the countries to be able to mobilize samples, especially to identify as biological and infectious contagious from one place to another, because that is a risk that is very important and because it requires a lot of processing. And finally,
to hear a little bit more about the vaccine procedures for both condors and vultures, because it sounds commonly pretty easy, but if we can talk a little bit about the challenge to handling, to manage the animals, and of course to vaccinate them. So, y además agradecerles a todos su dedicación y su trabajo.
And also to thank everybody for your time and dedication, for your work and dedication, sorry.
Doctor Lecona, la primera pregunta que nos hace.
I will answer the first question. Effectively, the majority of the what corresponds to wild birds, the virus that we identified was H5N1. And this is also related to the fact that it was the surveillance that was carried out directly in Mexico. The majority were ducks, migratory ducks. But regarding the species, we don't have them in the bulletin, all the species, but nevertheless, that information is something that we can obtain without any problem. The species that we identified, in which we identified the virus of H5N1, and we also the N3, but we don't have that indicated in the bulletins. But if you want that information, we can look it up and share it with you. Mr. Bendaño. Hello, can you hear me? Yes.
¿Me escuchan?
Muy bien.
Can you hear me?
Perfecto. Sí, con referente a la consulta.
With regard to the question, at the same time, we were
movilización de muestras, como mencioné.
Working on the topic of mobilization of samples. As I mentioned, the two labs that are going to be used
estas muestras,
to be able to process the samples
Con Panamá ya
One
se
is
tiene
in Guatemala
experiencia,
and the other one is in
ya que ahí
Panama.
se encuentra el laboratorio, digamos,
With Panama, we already have the experience
ya a los países de la
because there we have the lab
temas
that
de
supports the countries of the region
tos,
for
el OIC
topics
ya
of
tiene
vesicular.
un
So they already
mecanismo
have mechanisms for mobilization of samples towards Panama.
para el tema de influenza aviar,
That practically, for the topic of avian flu, would provide the service to Nicaragua, Costa Rica,
en
Dominican
cuanto al
Republic.
laboratorio que está en Guatemala, se pretende que pueda dar el servicio
In regard to the lab that is in Guatemala, we provide the service to Belize, Honduras, and El Salvador.
nuestra vía
El
terrestre.
Salvador, we have had a sample of moving samples at through land. And the countries also have staff that is certified within the YAPA to be able to do this mobilization of samples.
Y se dan también capacitaciones para el embalaje.
And we also provide training for the packaging
Casos también
of the material that is infectious contagious. And this is also something that is approved by the ORISA in the labs of the United States. But we are working on the protocol, specific protocol, to be able to do the modification of this sample towards this labs initially.
Over to you, Dr. Suarez.
And Dr. Suarez,
Okay.
your question.
I'm not sure I understood what the question was. I can tell you a little bit more about the vaccine and condors. I think that was what the question was.
Yes, it is. Yeah.
So yeah, the vaccine that we ended up using was it was a commercial product that was licensed in the US. So it went through the approval process through the Center for Veterinary Biologics, but it was never used. It was the vaccine that was purchased as part of the vaccine bank that we had established back in 2015. All that product ended up expiring, and so the company actually had made a new serial of that vaccine. And again, it's just a whole virus. It's a reverse genetics made vaccine. So it's a low path virus, but genetically it was very similar to what was circulating in 2015. And so they just inactivate that virus, add the adjuvant, and it's the same product again that's used, would have been used for commercial poultry. The condors themselves, again, because they have a large breeding population, almost all the animals that were vaccinated were from these breeding populations, either birds that were about to be released into the wild or just breeding stock, birds that were living in zoos. So that is part of how they were able to vaccinate the condors. But I did mention that they do have a process where they try to recapture the birds each year to try to test them for lead levels and provide treatment for lead toxicity. And so that would provide them another opportunity to do that. So that process, that program is still ongoing. Over.
Thank you, Dr. Suarez. I'd like to invite Runa from our task force. We can take 2 more questions.
Thanks, and I'd like to thank the presenters and very interesting morning. I have a couple of questions, one for Dr. Ramiro. So you said most of your sampling was focused on birds, right, the wild birds, and were there any cases of carnivorous mammals?
So not birds, but mammals.
Yes, I was asking about the carnivorous, because that was a very common finding in Canada and US.
Los animales de Canadá es más
Raccoons,
bears.
Oye, no alcanzamos a escuchar.
Sí, es porque estoy traduciendo al mismo tiempo. Entonces, como osos o mapaches, no aves.
Ok, animales
Carnívoros.
mamíferos.
Sí, mamíferos.
Que sí hemos detectado en México. Sí hemos detectado en México la presencia de virus en...
We have detected in Mexico the presence of this in mammals. In Mexico, we carry out the surveillance also. It is also in some of the cases, suspicious cases, with breathing problems, respiratory problems, but we have not had detection in other species.
Sí, pero no results.
Okay, thank you. I have a question for David. David, it was very interesting about the bovine detection of avian influenza in cattle. And
Tengo otra pregunta de la detección de esto y simplemente quiero saber qué tanto tiempo.
do you see antibodies in the milk?
I'm sorry, can you repeat the question? It somehow got translated back into Spanish and I don't speak Spanish.
Sorry, David. I was just interested in cattle, how long it takes for the animals to seroconvert and whether you will see the antibodies in the milk.
I mean, we can see antibodies in the one experimental trial that was done at NEDC. I believe they could detect antibodies as early as 7 days after experimental challenge. The work to actually look for antibodies in the milk is ongoing, so I don't have that data, but based on the data in the 50s, again, they were able to detect antibody again as early as 7 to 10 days. So I think it happens very quickly. And again, most of the replication appears to be localized to the mammary gland, and so that antibody in the milk is very important for the inactivation of the virus.
Thank you. So this, right? That's okay. And then the other question I have is, I have seen in the markets these ultra-filtered milk. Are they pasteurized as well, or they are only filtered? And what's the risk associated with those?
Right. Well, I mean, in the US, any milk that is going across state lines has to be pasteurized. And so, yes, I think that I mean, there's multiple different ways of doing pasteurization. And so there may be some different approved ways that they've pasteurized the milk. And so I'm not sure exactly what type of milk that you're saying, but if it is crossing state lines in the US, it has to be pasteurized.
Okay. And the last question is about the slaughterhouse workers. Is there a risk associated with it? Like if the infected cattle coming into the slaughterhouses and people who process the meat?
So as far as I know, there has not been any necessarily special precautions of what the slaughterhouse workers are doing. And there have been no, human cases in the slaughterhouse. And the only human cases that we've seen has been in the dairy workers themselves with the 3 cases that were reported. So that, and again, whether the virus is in the meat or, and certainly it is in some of the tissues if the animals were coming in while they were still infectious. But at this point, we don't consider that, or I think the risk is considered to be low that slaughterhouse workers would be exposed.
Okay, thank you.
Fantastic. Thanks for all those questions. My thanks to the panelists. We can't take any more questions. I have to follow a certain schedule, but at lunch, feel free to talk to if it's a question for Carlos. My thanks to all the morning presenters. We will take a 90-minute break. We will be back at 1 o'clock Mexico City time, local time. So that's 3 o'clock Eastern. And my thanks to the interpreters and to the logistical staff. We'll review how we can improve a bit the sound with the mics in the room and the online experience. We'll see you back in 90 minutes. Thanks, everybody. Entonces, vamos a comer afuera a la izquierda, en el patio. No hay